Android Atlas. Welcome to this explainer on Kotlin Coroutines, Episode 1. So, you've probably heard coroutines called lightweight threads. Honestly, that one phrase has confused more Android developers than any other sentence in Kotlin. And, well, we're going to kill it right now. 8 episodes, 35 concepts. Here is the series overview we are building together. We'll move from the absolute basics here in Episode 1, right through structured concurrency and error handling, all the way to real Android patterns in Episode 8. Let's start at the very beginning. Section 1. Problems coroutines actually solve. Before we can accurately define a coroutine, we really need to know the pain it was built to fix. You see, Android development in the pre-coroutines era had 3 big headaches. First, thread cost. Creating and managing threads is expensive. It eats up memory, adds overhead, and introduces a lot of complexity. Second, callback hell. To do anything asynchronous, you'd end up nesting callbacks inside callbacks inside callbacks. Code that should read top to bottom looked like a sideways pyramid. Third, thread communication. Getting results back from background threads meant posting to handlers, using live data pipelines, or juggling shared state. It was incredibly error-prone. Developers needed a better way. We needed a way to write asynchronous code that performed background work, stayed responsive, avoided UI freezes, and still read like normal sequential code. Coroutines are the answer. But to understand how they do that, we first need to understand what they actually are. Section 2. What is a coroutine? A coroutine is a unit of work that can start, pause, and continue later. That is the exact definition, and trust me, every single word in that sentence matters. Think of reading a book. You're on page 125. You place a bookmark, close the book, and come back later. When you open it back up to page 126, you don't restart from chapter 1. You continue. A coroutine is exactly like that bookmark. It is a task with memory. It knows where it paused, what it was doing, and what comes next. Need to download a user? That's a coroutine. Load a feed? Coroutine. Save to a database or process a payment? Those are coroutines too. Each one is a discrete unit of work that knows how to pause and pick back up. Now, there are 2 myths we need to kill immediately. First, coroutines are not Android-specific. They are a core Kotlin language feature. They work in back-end Kotlin, desktop Kotlin, multi-platform Kotlin. Android just happens to be where most of us need them first. Second, coroutines are not magic. The work still requires CPU, memory, and resources. A coroutine simply gives you a much better way to organize that work. Section 3. Coroutines versus threads. Let's kill that lightweight thread phrase properly right now. Threads and coroutines do not compete. They solve fundamentally different problems. A thread answers the question of where work can execute. It provides a call stack, a program counter, an execution state. Without threads, nothing runs. The thread is the worker. A coroutine, on the other hand, answers how we organize asynchronous work. It's not about execution infrastructure, it's about expressing work that might need to pause and continue. Think of a thread as a chef in a restaurant. The chef provides the ability to cook. Without a chef, nothing gets made. A coroutine is the recipe. The recipe describes what to do. Chop onions, boil water, bake for 30 minutes. But the recipe can't cook by itself. It needs a chef. Recipes run on chefs, but recipes are not chefs. Just like coroutines run on threads, but coroutines are not threads. Another way to visualize it, a thread is a movie screen, and a coroutine is a movie. Movies run on screens, but movies are not screens. The exact same screen can show different movies, and the same thread can run different coroutines. That is the relationship. They are related, dependent, but fundamentally different things. Section 4. The superpower of suspension. Here is what makes coroutines genuinely powerful. This is the exact thing threads cannot do. Suspension is pausing the coroutine without blocking the thread. Watch the difference closely here. The chef puts a pizza in the oven. The pizza takes 15 minutes. Option 1, the chef stands in front of the oven for 15 minutes, doing absolutely nothing. No other orders get made. The whole kitchen freezes. That is blocking. That is exactly what thread.sleep does. It's what happens when you call a network API on the main thread and your app completely freezes waiting for a response. Now, look at option 2. The chef puts the pizza in, walks away, and starts working on other orders. The oven cooks, and the chef remains productive. When the oven beeps, the chef comes back. That is suspension. The coroutine pauses, but the thread keeps working. And to be clear, this is not the same as thread.sleep. Thread.sleep blocks the thread. The chef stands at the oven doing nothing. Suspension releases the thread. The chef walks away. The thread is completely free to do other work. And remember, suspension doesn't destroy the coroutine. It still exists. It's just paused, waiting, ready to continue. Now, the oven beeps. The chef comes back. That is what we call resume. You continue from exactly where you paused. You don't restart, you continue. But here is the key detail that most people miss. Something causes the resume. The coroutine doesn't just wake up spontaneously. A network response arrives. A database query returns. A timer fires. Something external triggers the continuation. The food arrives at your table and you return to eating. That is the trigger. And one more nuance for you. Resume does not mean same thread. The coroutine might resume on a completely different thread than where it started. That's a detail we'll explain fully in episode 5 on dispatchers, but just file it away in your mind for now. Section 5, Suspension Points and Recap. Here is a detail that most tutorials skip entirely. A coroutine cannot just pause anywhere. It can only pause at specific approved locations called suspension points. Think of a train. A train doesn't just stop in the middle of a bridge or halfway through a tunnel. It stops at stations. Stations are predefined, approved locations. The train knows exactly where it can stop. Stopping anywhere else mid-journey is just not allowed. Suspension points are exactly the same thing. They are specific spots in your code where the coroutine is actually allowed to pause. If the data you need is already cached, the coroutine passes right through the station without stopping. Green light, get moving. If the data isn't ready, the coroutine stops at the station and waits. Amber light, passengers board later. This is critically important. A suspension point does not mean suspension always happens. It just means suspension is allowed. The train might pass right through a station without stopping if nobody needs to board. And here's what this implies. A coroutine cannot suspend at random locations. The behavior is entirely deliberate and predictable. It's not chaotic. But this raises a question you might already be asking yourself. Who places the stations? Who decides where these approved locations are? Well, you do. With one single keyword. And that is going to be the subject of episode 2. Before we close out, let's lock in the 4 things most developers get wrong about this layer. Number 1. Coroutines are lightweight threads. No, they are different questions and different tools. A thread asks where, a coroutine asks how. Number 2. Coroutines make work free. No, work still needs CPU and memory. Coroutines just organize it a lot better. Number 3. Suspension stops the entire app. No, only the coroutine pauses. The underlying thread keeps right on working. And number 4, resume means restart. No, it means continue from exactly where you paused, not from the beginning. Let's do a quick final recap. A coroutine is a unit of work that can pause and continue. It is not a thread. A thread provides execution, while a coroutine organizes async work. Suspension is pausing the coroutine without blocking the thread. Resume is continuing, not restarting, and it's always triggered by an external result. Finally, suspension only happens at specific approved locations called suspension points. Which brings us to the ultimate question. If coroutines are just tasks with memory passing through approved checkpoints, who exactly is laying down the tracks, and how does Kotlin remember the state of the world when the train pauses? Think about that for a bit. We'll explore the suspend keyword and continuations in episode 2. Thanks for watching this explainer.